Hello all, welcome to my channel. In this video, we will try to answer the question why a voltage divider cannot be used as a power supply. So let's get started. To answer this question, you first need to understand what a voltage divider is. If you don't know what a voltage divider is, or if you want to refresh your memory, you can watch my video that is displayed in the top right of the screen here. Let me take a practical example uh, to answer this question. You have a 12-volt battery source and you have a bulb, a small DC bulb, which can operate on 5-volt supply. As an engineer, you have to find a way to drive this bulb from this 12-volt supply. The very first thing that comes to uh, most of our mind is to use a voltage divider network. I mean, it's not a bad idea, so let's see how to do that. You have a 12-volt supply, and to get 5 volt you need to connect two resistances in series. One of value 7k and the other of value 5k. So the voltage across 5k will be 5 volt and the voltage across the 7k will be 7 volt. This is good. Now we have achieved one part of the solution. So we have got the 5 volt required for the bulb. Let's try to connect the bulb across this 5 volt terminal and see what happens. So you have the 12 volt supply, 7 kilo ohm followed by the 5 kilo ohm and a bulb. Okay, and this bulb usually has a resistance from somewhere around 5 to 10 ohms. The resistance comes from the filament of the bulb. So let's assume it to be 10 ohms for this case. So this bulb uh, has a 10 ohm resistance and requires an operation voltage of 5 volt. So once you connect this bulb to the network can be represented as below. So this is a 12 volt network. Again we have 7k followed by 5k, and then this bulb can be modeled as a 10 ohm resistance. Okay, and to find the voltage V2, which is of our importance since the bulb is going to use this voltage to drive itself, you first need to find the current I in the network, and you need to find the total resistance applied across the 12 volt supply. And to do that, you need to first solve this parallel combination, and this parallel combination will lead to a resistance R, equivalent resistance R, that is 5000 into 10 divided by 5000 plus 10. So this will be 9.98 ohms. Roughly we can take it as 10 ohms. So the circuit again further reduces to a 12 volt supply, 7 kilo ohm and 10 ohm resistance. Now to find the voltage divider, you need to find the current I. I is nothing but 12 divided by 7000 plus 10, and the voltage V2 will be nothing but I into 10 ohms. which is 12 into 10 divided by 7010, which is approximately 0.017 volts or 17 millivolts. Now let's try to put everything together and understand what happened here. So the effective network that we had initially was a 12 volt network, 7 kilo ohm resistance, 5 kilo ohm resistance, and assume we had a switch here which connects to the bulb. Which requires 5 volt and has an internal resistance of 10 ohms. Okay, before we close the switch, the voltage across these 2 points was 5 volt, and the bulb also required 5 volt, so we were good till here. And once we close the switch, the voltage here is no more 5 volt, it has dropped down to 17 millivolt. If you clearly understood how a voltage divider network works, the voltage across R2 is directly proportional to the value of this resistance R2, and as soon as you connect a load of some resistance Z to this network, the resistance between these 2 points is no more R2, it is R2 parallel Z. Therefore, the voltage will also change with respect to this new resistance R2 parallel Z, and that is the reason you cannot use a voltage divider as a power supply. In my further videos, I'll try to show how to use the voltage divider network as a power supply, of course by using extra circuitry. So stay tuned and subscribe to the channel. Thank you.